Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab and just scroll down in the search question, search linked list cycle and hit enter. So in the previous video, we have done the linked list cycle which come under the easy category. Now we will do the linked list cycle part 2. Why we are doing this? Because it is more or less same, only a little bit modification, very little modification. All right. And they said it's come under the medium category. Anyhow, let's click on it. So the question is like same, given the head of a linked list. So head of the linked list is given and return the node where the cycle begins. In the previous question, we have to return true or false whether in the linked list there is a cycle or not. But now in this question, we need to return the node. We need to return the node where the cycle begins. So as an example, if you take the example of 320 minus 4, so the node from where the cycle begins, that is 2. So we are going to return the node 2. If there is no cycle, then we are going to return null. And that's it. So why this question is similar to the previous question? Because first, at least we have to check whether there is a cycle or not. All right, because that part is same. Because if there is a cycle, then only we can return the particular node. Then we will check how to return. But at least we have to perform whether we have to check whether there is a cycle or not. Right. So how we are going to check whether there is a cycle or not? So we see in the previous video the two method. One is using some extra space and one is without using extra space. So let's try. So we have nodes 3, 2, and 0 and -4. Right, and 4 is connecting to the 2, and the rest of the nodes are connecting. Sorry, so let me erase this. So here 2, and rest of the nodes are connecting with each other. So this is given. All right, so how we are doing? So what we are doing is we are putting our head pointer here. So currently the head pointer here. Then we will check. We will take some storage, and we will place 3 here. We will check like if this 3 is in the our storage or not. If it is not, then we will put our 3 here. Then we will move our head pointer here. So our now head pointer is pointing here. So let's remove this head pointer. So now we will check 2 whether 2 is there or not. So 2 is not there. So we are also going to put 2 here. Then we are going to move our head pointer further. So now our head pointer is here. All right. So let's remove the previous head pointer. All right. So then we will check whether 0 is in the storage or not. So 0 is not. So we are going to put 0. Then we are going to move our head pointer further. So now our head pointer is pointing to this. All right. So our head pointer point to this. We will check whether -4 is in the storage or not. So -4 is not in the storage. So we are going to store -4. Then our head pointer going back to the sorry 2, because 4 dot next is 2. All right. Then we are going to check whether 2 is in our storage. So yes, 2 is in the storage. If 2 is in the storage, then there is a cycle. And at which point the cycle begins? That is the 2, because 2 is the point, the the node which is going to repeat it, that is the cycle point. So 2 is the cycle. So we are going to return this node. All right. So let's try to implement this. So how to do that? Exact same thing like which we did in the last video. So what we have to do, while head, we have to take some storage. So s is equal to set. While head, we will check if head in s, that is set, then we are going to return head, because we need to return the node from where the cycle begins. If particular node in the set, it means that node already come. So that is the point. So cycle started from that point. So return head. Right. Else what we are going to do is s dot add. Then otherwise we are going to return the particular node into our set, and we are pointing our head pointer further, and otherwise we are going to return none, because otherwise we are going to return null. So let's run it. In the previous video, we are just returning true or false here. That's it. But in this video, we are returning the particular node. So let's try to run it. So our all three test cases has been accepted. So let's try to submit it. So our solution has been accepted, and but it is consuming a lot of memory. That is, we only be 20% of the people. But if you go scroll down, there is a follow up. Can you solve it using O of 1? That is the constant memory. All right. So in the previous question as well, like there is a follow up. Like, can you solve it using the like constant space or not? All right. And like in the last video, like I told you to solve into the constant space. Whenever like we have to solve in the constant space, we have to think about the two pointer approach. So let's try the two pointer approach. 3 2 0 minus 4. And in this video, we have shared, like we will take the two pointer. One is the slow pointer. So let's suppose this is the slow pointer and one is the fast pointer, and this is the fast pointer. All right, this is the fast pointer, and there is a cycle from 4 to 2. All right, and like all these are like interconnected. Okay, so first we have to check whether there is a cycle or not. So what we did in the last video, we will move our slow pointer by one step, and we will move our fast pointer by two step, and we will check whether the fast pointer can catch our slow pointer or not. If it can catch, then it means there is a cycle. Then the next part is we have to find this particular node from where the cycle begins. That is a different part. First we have to do the at least the half part. So how to do? So first we will move our slow pointer. So slow pointer will move here, and the fast pointer will move here, because fast pointer will move by two step. So fast pointer will move here. So let's remove the previous pointers, right? And then fast pointer will move here, because fast pointer will move two steps. So minus 4 and 2. So fast pointer will move here. Fast pointer will move here. So here is the fast, and slow pointer will move here, because slow will go here. So let's remove this, and let's remove this. All right. Then slow pointer will come here, because slow pointer is moving step by step, and fast pointer will also come here. So fast pointer will also come here. So let's remove this. Right. So now our fast pointer has catches our slow pointer. So it means there is a cycle, but we don't have to detect the cycle. We have to return the node from where the cycle begins. Okay, we detected the cycle, but we have to return the node from where the cycle begins. But 4 minus 4 is not the node from where the cycle begins. 2 is the node from where the cycle begins. So how we are going to return the node 2? All right, so that is the question. So half part is done. So what about the last part? So in this question now, so if you observe, if you take the starting node, so starting node is this head. All right, so because like there is a head pointer, so there is a head pointer, and head is always pointing to our starting node until unless we are not moving. So we are moving only like slow and fast pointer. We are not moving our head pointer. So head is pointing to D. So we have to find this two node. So this two node, how much step far from the head pointer? It is one step far from this pointer. And how much step it is far from this slow pointer or fast pointer? Only one step. All right. So it means or this that it will be always remain the same thing. So it means like what we can do, as soon as we find the cycle, what we can do is we will start moving our head pointer, and we will start moving our slow pointer. And as soon as our slow and head meet, it means we found the node. So as an example, so we are going to move our head pointer. So now head is here, right? And we are going to move our slow pointer. So slow is here. So now slow is here. So we will move our slow pointer. So let's remove this. And let's remove all this. All right. And we will check whether the head is equal to slow. Yes, the head is equal to slow. Then we are going to return that particular head. All right. So if it is here, then so maybe like two distance. Let's suppose the cycle begins at the zero. So maybe the it's not maybe definitely the distance from the head equal to the distance from the slow pointer, and that is the meeting point. So let's try to run. And in this question, we are not using the extra speed. So we have to take the two pointer. One is the slow pointer and one is the fast pointer. All right. And we have to run a loop while head not equal to none and sorry, not head while slow and fast not equal to none and fast dot next not equal to none. Why we are like writing this, like you can watch the last video. And because fast dot next for the, like if there is a one element, otherwise slow dot next fast dot next we have to take. Then we what we have to do, we have to move our slow pointer by one step, we have to move our fast pointer by two step, next dot next. And then we will check if slow equal to fast, it means there is a cycle, then we have to do something, otherwise we have to return none. If slow is equal to fast, like earlier, but like what happens, so slow and fast pointer at -4, then what we have to do, we have to then run again a loop to move our head pointer and the slow pointer. Then what we will do, if slow is equal to false, then we will move our head pointer while head not equal to none. All right, so head is equal to head dot next, slow is equal to slow dot next, or fast is equal to fast dot next, because both are like pointing on the same node. So if head equal to slow, then we are going to return head. It means like when we will, like earlier, here are the slow and here are the fast pointer. So here it is the slow and here is the fast pointer. Both are pointing on the like node -4. So and but the actual output is 2. So how much distance it far from the head? So it is only one distance far, and it is only from one distance far from here, like 4 to 2, only one distance, that is the next node. So what we can do is, and this will remain like even if you take like even long list, it will like the answer will remain the same. So what we can do is we can move our head pointer, we can start moving our slow pointer as soon as it met. When wherever it met, that is the meeting point, and that is the node we want to return. All right. So the same thing we are doing. If slow is equal to fast, then we will move our head is equal to head dot next, slow is equal to slow dot next, and if head is equal to slow, then return head. So let's try to run it. So something is wrong. So and slow not equal to none, maybe. So it is failing in one condition. Case one, case three is fine. Case two, there is a node one, node two. So node one, node two. So let's see for the node one and node two example, because for that our test scenario is failing. So let's see like what we are doing wrong. So node one and node two. So node one and node two, and there is a cycle. There is a cycle here. So in the starting, we have slow pointer here, and we have fast pointer here. All right. So we will move our slow pointer by one step, and we will move our fast pointer by two steps. So one fast pointer will move here, and then it will come to this step again. Okay. So now fast pointer will come again here. Then we will move our slow pointer again and fast pointer by two step. So slow will come here, and fast again will come here. Fast will at the same place. So slow and fast matches. So if slow and fast matches, right? If slow and fast matches, then we have to, what we are doing is we are doing head is equal to head dot next. So the head is also this pointing to this, head is equal to head dot net. slow is equal to slow dot next. So head is equal to head dot next. So now head will come here and slow will also come here. Okay. And then if we are checking head is equal to slow, yes, has it head is equal to slow. I think before we are checking, we have to do that. So maybe if we return head, maybe we have to do like this. Let's try to run it. Yeah, so now we all cases are subsetted. So let's try to submit it. Yeah, now like our solution has been accepted, and we see last time only we beat 15% of the people in the memory, but now we beat 51% of the people. So like it's a very similar question as part of the linked list cycle. So because we have to first tell whether there is a cycle. If there is a cycle, if you follow the memory approach, then it's totally same. There is no difference. Instead of returning true and false, we have to return the particular node, because anyhow the particular node reaches. If we have to use this approach, where we are using the constant space, where we are using the constant memory space, then we have to detect the cycle. How to detect the cycle? This part is same. We will take two pointers, and what we will do, as soon as like we found the two pointers, we know like as soon as it's going to matches, as soon as it's going to matches, we know like the starting node, the cycle node from where the cycle will begins, is one distance far from the head node, and like the same distance, not one but the same distance far from the head node, and the same distance far from the node where the slow and the fast pointer met. So that's why we start moving head and slow, so that wherever the head and slow met now, and that is the our meeting point. So that's it. That's the end of the video. And so sorry, yeah, we have already submitted. Yeah. So that's the end of the video. Thank you. You can also try it.